Thank you for the introduction, and thank you very much for the invitation to come and visit with you here and speak to you. I have been here for a couple of days, so I'm over the jet lag and really have appreciated getting to know Dresden. And so thank you very much. As Wolfgang said, I am a ecosystem ecologist, but really I spend a lot of my time now working at the intersections of very different disciplines or domains, so social sciences, engineering, design, futures, sustainability scientists. So we specifically focus at the intersection of climate change, especially extreme events, and urbanization and urban systems. So today I'm going to feature the approach we've developed for co-producing visions of positive futures for cities, using case studies derived from several projects that are, you can see the logos of those projects, and I'll try to introduce and acknowledge my collaborators, which are many as we go, but I want to mention them here as a group and thank them for any of the great ideas that you're going to hear today. Okay, so as you all know, we live in challenging times, and I'm sure you've all seen this graph. These rapid changes that we see in socioeconomic trends leading to trends in the Earth system that are all accelerating. So this is a rapidly changing world, and what this doesn't show is the importance of feedbacks within the Earth system, which include people. For example, the rise in surface temperature driving energy use or water use, the degradation of the terrestrial biosphere driving urban population growth, and so forth. So these are other characteristics that are defining for this era that we call the Anthropocene of rapid change. Complexity is increasing, the complexity of systems, the complexity of the problems that we're facing. There's also increased inequality, for example, with rising disparities between the global north and the global south and widening income inequality. And there's increasing uncertainty. So one clear case being the non-stationarity problem, where probabilities of extreme events are changing over time, so we can no longer use the past to predict the future. So if we think about climate change, what you often hear in discussions of climate change is the focus on global mean temperature, keeping temperature increases below 1.5 or 2 degrees Celsius. So that number actually belies a lot of changes that are associated with the changing climate. Here we see this seasonal pattern of variation in global mean temperature that you can see I only got through 2023. That line continues to be well off the rest of the curve. So 2023 was the hottest year on record. But besides temperature, we've also seen changes in the frequency and magnitude of extreme events. And these are data from Munich Re insurance company showing increases in extreme events between 1980 and 2017. And what you see there is everything except for the red bars are climate-associated events. So all of those climate-associated events showing increases over time. In fact, people experience climate change most immediately and most urgently through extreme events, and that's especially true in cities where most people are concentrated. But an ugly reality emerges when we look at the impacts of extreme events. Those who are least able to cope are often disproportionately affected. And the graph on the right, what you can see is the projected economic damage due to climate change being highest in the US counties that are the poorest. So my team has been working in urban ecosystems. So my talk today is coming from that urban perspective. Cities are particularly vulnerable to extreme events, given the fact that they are located in areas that are along coastlines, sometimes in drylands, along rivers, and they concentrate people, not only people, but also the important infrastructure that supports cities. And the world is urbanizing at the same time, so most of the population growth we expect in the next half century will be in cities. And in fact, most of that population growth will be in the less developed world, or the so-called global south. So thus, the intersection of urbanization and climate change, especially extreme events, is really, makes it really important to understand how urban ecosystems can build resilience to these extreme events. So given that background, in 2015, we established a network, the Urban Resilience to Extreme Sustainability Research Network, to research how to build resilience to extreme events. And we focused on the 4 types of extreme events that you see at the top: coastal flooding, extreme heat, drought, and urban flooding or pluvial flooding. And we included in this network 9 cities that were in the US and Latin America, really different cities, for sure. There were 22 institutions involved, over 170 researchers, over 130 practitioners, 16 postdocs, 65 grad students and associates. And I think several things came out of this project and are still emerging from this project. But the key advances that I want to talk about here are, first, the conceptual framing of social-ecological-technological systems, or SETs, which I'll talk about more. And then secondly, the co-production with city teams of government officials and managers, community leaders, non-governmental organizations, academics, of 60 future scenarios, stories about possible futures that are told with a positive spin, so this idea of positive futures. So these 2 ideas are going to organize the rest of my talk. And the illustrative cases that I'll talk about are mostly from Phoenix. It's an area I know best, having been there some 46 years now. So just wanted to say a few things about how I got here. In 1997, I was the founding co-director of the Central Arizona Phoenix Long-Term Ecological Research Site, which is now in its 27th year. It was this guy, Chuck Redman, and I that founded that together. It was really Chuck's fault that I got involved in urban ecology at all in the first place. We then, after many, many years, came back together in 2014 to write this proposal for the UREX SRN project. And then from that, a number of other projects have emerged, including SET's Convergence Project and the Nature-Based Solutions for Urban Resilience in the Anthropocene, Natura. So I will talk about those more as we move on. So first, I wanted to bring to your attention this idea in the developing SETs framework that the way we design our cities and the infrastructure in them needs to embrace a framework that is more realistic for the Anthropocene. So the perspective that has sort of dominated the development of infrastructure, the development of our cities and so forth, is this control perspective that holds that the world is stable, that systems are complicated but not complex, that we can understand them, that they're probably pretty linear, that events are predictable, that we know what those probabilities are. Again, that reflecting back on Mark's comments, that humans are separate from nature. That's been the perspective that has been dominating. That we value an emphasis on utility and efficiency, and that social, ecological, and technological systems are isolated from each other and decoupled. Well, all of those things are wrong. They don't really fit the reality of the world that we're living in. So the world, as I said, is rapidly changing. These systems are complex. There's a lot of nonlinearities, feedbacks, et cetera. We don't know what is going to happen, though, the probability of events. We don't even necessarily know what the outcomes we're thinking about are. And humans and nature are inextricably linked, even if we don't acknowledge it and our society doesn't acknowledge it. We depend on ecosystems for our survival. In this sets perspective that we're advocating, we value an emphasis on diversity and pluralism rather than a single approach to efficiency and utility, and recognize that social, ecological, and technological systems are integrated. This is a figure that comes from a paper published last year in Urban Sustainability, which you can look at there. So from this control to this entangled sets perspective, what we're recognizing is that social, ecological, and technological systems can be brought together to improve this idea of making sense of the problems that we have. So we really need to move beyond this traditional systems thinking approaches to advising and understanding decision-making within and for entangled sets. So these urban resilience problems that we have are problems of complexity, so we need convergence. Cities have social, ecological, and technological elements that interact, and the urban resilience to extremes events actually emerges from the interactions and feedback among those three domains. Finally, building resilience means that we need to enhance capacities to adjust, adapt, and transform toward desired futures. So given that background, I want to move into talking about nature-based solutions and future visions. So the question that we might ask is whether nature-based solutions can build sets resilience to floods, extreme heat, and other extreme events. And then finally, do people actually incorporate nature in their future visions? And so we'll go through some of these future scenarios that we've constructed or co-produced with cities, but I'm going to back up a little bit and tell you a little bit about Phoenix. Phoenix is a fast-growing southwestern U.S. city located in a hot, dry climate. Its population has grown more than tenfold in the past 70 years, and that growth continues. So people keep moving to Phoenix. We have close to 5 million people in the metropolitan area now compared to less than 500,000 in 1950. And Phoenix was founded after the Civil War in the United States, 1880 or so, and it was really initially based on irrigated agriculture. But growth really took off in the 1950s when boosterism of this city in the Southwest promoted the idea that this desert city could be an oasis. We could water the desert and have farms and gardens and so forth. And so these two postcards on the left are from the early 1900s advertising Phoenix. And what you can see is that there's been really quite a lot of hydrologic modification that has enabled the establishment of this supposed oasis in the desert. So the photograph in the middle is the Central Arizona Project Canal, which brings water from the Colorado River in the perpendicular to the natural flow lines down to Phoenix, Tucson. You can see the effects of urban development in the bottom photograph on the natural landscape. And the upper right shows us how water has been captured upstream of the river that flows through Phoenix, or actually no longer flows through Phoenix, to support irrigation of agriculture and also municipal use. Today, people in Phoenix enjoy lush gardens and swimming pools owing to the capture of water from that local watershed. And this has resulted in the complete dewatering of the city's river. So I want to zero in here on a designed system for stormwater management that is shown in the bottom photo, the second from the left there. This is Indian Bend Wash. And this is a designed stream. It's the green belt of Scottsdale, Arizona, called Indian Bend Wash. In the 1960s, people had started to You can see in the photograph on the right from 1930, there was mostly farmland and a pretty broad ephemeral channel which flowed in response to rain events. But in the 1960s, the region had started to urbanize and people started to build in the floodplain. And as a result, there was a plan to basically to channelize this ephemeral stream, assuming that they could control the flows of the 100-year event within this big channel. But the people in Scottsdale said, ain't no way we're going to do that because we do not want an LA river in Scottsdale. So through citizen activism, this plan was actually changed, and the Army Corps of Engineers of the United States, which is responsible for a lot of stormwater management, instead constructed this green belt that you see in the aerial photo in the bottom left, which is an idea of managing floods rather than controlling them. So again, getting rid of that control paradigm, allowing the natural flood regime to occur, but really playing around with this idea of consequence versus probability. So the idea of the probability of an event, working with that is a sort of standard way that, that stormwater systems are designed. But instead what we're saying is, okay, we're going to let it flood, but the consequences are going to be minor. The consequences are minor because there's room for this stream to go. And I noticed and heard about the river here in Dresden actually having a bit of room for the river, which is excellent. So this is just to show you what the greenbelt looks like from the air today. And this is actually what it looks like on the ground when it's flooding. So there are some low water crossings where people can't cross during floods, but there also are some bridges. There's actually a bike path that goes along the stream, so lots of recreation in this area. And you cannot bike during these events because it fills up. So this is what we call a safe-to-fail system. And again, this idea of playing with the product of probability and consequence, here we say the safe-to-fail system allows for more frequent failure, but with minimal consequence. So when those floods happen, well, there's some things that have to be cleaned up in the lawns, and possibly some garbage cans tip over, and they're all cemented down, so they have to be picked up again. But really, engineers are becoming increasingly interested in incorporating resilience concepts from ecology in their risk framing. So this is an example of something that allows that. Blending the ecological with the technological provides a resilient nature-based solution. This is not an idea of restoring the stream to what it originally was like, but rather designing a system that is safe to fail. Okay, now I'm going to talk a little bit about heat and nature-based solutions for resilience to extreme heat. I want to start by going back to a portion of Phoenix, South Phoenix, which is a historically marginalized community south of the Salt River. South Phoenix, as you see in the photograph, used to support lush trees along lateral canals that were bringing water from the Salt River. The river was flowing then in the early 1900s before the last dam was closed in 1938. But there was major river flooding in the early 1900s, so most of the white population moved way north of the river, and there was redlining, which is a process by which people of color were not permitted to move away from that area, and so most of the Mexican immigrants and the black population were restricted to this area south of the river as late as 1960. It didn't seem like such a bad place at the time that these photographs were taken, but in the 1950s, there was this idea that trees, big trees, and open canals were stealing our water, and so there was a removal of all of this vegetation from this area. And so very little of this nice sort of more modulated climate existed later on. And this removal of trees led to this urban village, among others being among the hottest in the region. So what you can see in this map on the right is the heat vulnerability index, which is the higher heat vulnerability is in red and the lower in blue. And I've outlined the South Phoenix village there. The small green dots have to do with the number of heat deaths. And this is actually a serious issue in Phoenix today. We had this year 62 days over 46 degrees C, I believe it's 46, and more than 100 days over 40 degrees C. So it's really quite an issue, and some hundreds of people have died from heat-related illness. If you see on the bottom this exposure to high heat, this is for a particular event that was studied by one of the CAP LTER teams. And what you can see is that in the neighborhoods that had high exposure to this high heat in this particular heat wave, those that had the highest exposure had significantly lower income and a significantly higher percent people of color. So this is a equity issue as well as an issue for all of the people in Phoenix. So there has been some concern with the county health department as well as researchers and non-governmental organizations about what to do about the extreme heat in these poorer neighborhoods in the Phoenix area. And so in 2017, the Nature Conservancy launched a project called Nature's Cooling Systems with participation of these individuals that you see here, Maggie from NGO, the NGO from Nature Conservancy, and the others from Arizona State University. And we were really dedicated to developing neighborhood-scale heat action plans with residents in Central Phoenix, and in 3 neighborhoods, actually, that we picked in this area, and partnered with the County Health Department, Arizona State University, the UREX project, and these community-based organizations in each of these neighborhoods. So as I said, heat is an increasingly serious cause of death and illness in Maricopa County, which is the county that Phoenix is part of. And you can see in this map of the distribution of land surface temperature that it's very heterogeneous with both hot spots and cool spots. The big red blob in the middle is the airport, so it's very hot. But the 3 outlined neighborhoods are neighborhoods that we chose to work in for developing these heat action plans. So the selection criteria were that the neighborhood had high vulnerability, high exposure, low adaptive capacity. And if you can see for on the left there, the central Phoenix, the one that's in the center of the map, that neighborhood, just to give you an example, ranks among the hottest 4% of tracts within this area, among the lowest rank of NDVI, a measure of greenness in the area, and has a very high rate of heat deaths as well. So what we did for this is we did these community workshops to develop these heat action plans. And we did this through a series of 3 workshops. The first was to, with the communities, to map out the areas in their neighborhoods that they found to be extremely hot, that needed attention, what were the concerns of the neighbors, and so forth. In workshop 2, we invited designers, decision makers, people from the city parks department, et cetera, to hear those concerns. And we did this in a sort of fishbowl format where the designer sat in the center and the people came in and asked questions. And then thirdly, to make decisions about what the priorities were for implementation. And I just want to say about this that the most important part of this process was the involvement of community-based organizations that had already established relationships with residents and were able to come into this situation and bring people into these workshops to develop these heat action plans. We also engaged a group called the Center for Whole Communities in thinking about what they call whole measures for those heat solutions. So this is considerations of were the solutions just and fair, how involved was the community in the process, so how much procedural equity was there, how could this bring economic vitality and support resilience of the community. So in these three neighborhoods, there were both distinct and common strategies that were identified. We developed drawings, renderings of what these ideas were for these different areas. There were some commonalities in all of them. They wanted shade at the bus stops. They wanted more water available for people that were outside, and they wanted more trees. So each community created their own plan. Each community chose a spokesperson. We gave them training on how to present these heat action plans. Again, I want to emphasize that this community-based organizations were really critical for developing these heat action plans. Okay, now to move to the scenarios, the future scenarios that we developed. Again, I'll focus mostly on Phoenix, but I'll say a few things about the 60 scenarios that we developed. Scenarios are essentially tools to help us to vision what the future might look like, given different circumstances and decisions that we might make. So it's really just a plausible narrative about the future of a place or situation. But we also want to incorporate this normative element, which is what do people want to see? I mean, not just what could be, what the models say that the temperature will be, or what possibilities are in terms of economic feasibility, but what do people want? What do they want to see? So we base these scenarios on thinking about the year 2080, so really thinking far in the future, which is something that really is enabling for people that participate in this, because if you ask them to think about 5 years from now, they're going to think about all the things that are going to be the barriers to implementing these ideas. So we have typically 5 or 6 different themes for each city, and each one is, each table or each theme is a working group that creates this vision for the future. And it's usually a mix of people, as I said before, including government officials from different levels, city, state, county, national, community leaders, community-based organization leaders, business leaders, academics, NGOs, et cetera. So in the UREX scenarios, as I said, there are many. We have been doing an analysis of these scenarios to try to understand how many of these are really transformative visions, really changing the fundamental structure of these cities. And we found that about 73% of these visions were deemed to be transformative for at least one of the transformation archetypes that we used. These archetypes are, you probably can't see the lettering there. They are nature-human relations, infrastructure futures, managing and supporting transformative changes in the human-made structure, including soft infrastructure, governance, let's see what else, social justice, fair and equitable distribution of resources, opportunities, and privileges, reformed markets, so social, political, economic reorganizations, and then climate resilience. So those are sort of the archetypes that we were working with. And I don't want to say a whole lot more about this, except for that this is still ongoing, this work. But we were really interested to find that across these cities and scenarios, that there were some commonalities. For example, a lot of ideas about car-free cities or zones. I love that about Dresden, I have to say. Solar or decentralized energy infrastructure, connected green infrastructure, or nature-based solutions, a lot of attention to procedural and distributional equity, the fundamental right to housing, healthcare, and water, which, believe it or not, is a big debate in the United States, and the idea of creating these resilience hubs or community hubs in the area. Water-based transportation, that was even true in the city, the desert city where there's canals. So anyway, this analysis is ongoing, and I can't go into any more detail about it, but I want to go into more detail about the future scenarios for Phoenix. Here we have an academic team and a practitioner team that I want to acknowledge for the work that they did here. This was a project focused on problems of extreme heat today, as well as in the future, and visions for transformation of the city, visions for dealing with flooding, dealing with heat, dealing with drought, et cetera. And we conducted these scenarios, co-produced these scenarios with practitioners at 2 different scales, and these were at 2 different times. So on the local scale is this South Mountain Village that I mentioned earlier, and then the regional scale was for the Central Arizona Phoenix region, that you can see there. This is quite a large region, by the way. I gave this talk in Connecticut, and I said you could fit 5 Connecticut's inside to Maricopa County there. It's a very large area. So how do we do these? For each theme, we have, again, several themes. We give a background of what we know. For example, the number of days with maximum temperature above 100 degrees Fahrenheit, about 40 or 39 degrees Celsius, and you can see that we're already hitting what the projections are for mid-century. We give these sort of background on what we know, and then each group develops these really high-level goals, with the goal of what they want the city to look like in the future. Then they develop from a sort of a grab basket of strategies, which was actually created from pre-workshop surveys across a number of different practitioners and researchers, strategies that match each of those goals. Then they put some detail on those strategies. When would they be implemented in a timeline? Where in space would they be implemented? And then they finish the workshop with a narrative, which is sort of a day in the life of a person living in 2080 in this vision. So these are the 11 visions that were created at the regional scale and the South Mountain Village scale, or the smaller scale. And I won't go into each one of those, but there are some common themes across the 2 scales. For example, the true cost of water is a drought scenario. The desert wetland is sort of a flooding scenario. The mountain to river is also sort of a flooding scenario, et cetera, and so forth. But I'll just give you some examples. For the goals, this is an example of the kind of goals that were developed by this local mountain to river theme. The idea that development will recognize, so recognitional equity here, a community-held, environmentally, historically, and culturally sensitive vision, that the watershed management will reduce risk and hazard while providing beneficial use, and that eco-hydrological connectivity between the mountain and the river, this is an area, as you can see in the drawing, that exists between a mountain and mountain park and the Salt River. That connectivity between the mountain and river would align with human mobility and access. So that's an example of the kind of large goals that each one of these themes tables created. And the outcomes from these regional and local workshops were these tangible, positive futures. Eco-design and greening were prevalent in the regional scenarios. Honoring place and a concern for equity were most prevalent in the local scenarios. And I want to go through just a couple of examples to show how these workshop data are usable by researchers, design students, modelers, planners, et cetera. So we'll focus on the regional scale here and look at two of the scenarios. The first is a adaptive drought scenario. This is a scenario that was named by the group, the true cost of water, and it's really thinking about long-term water security, where water is conserved and banked for future use. And then the transformative Emerald City scenario. This is a scenario that is thinking about balancing the concerns about heat, drought, and flooding, and sort of matching those targets. So in the Emerald City, the idea was to repurpose freeways, to reduce reliance on cars, to create hubs where the canals and freeways cross, to concentrate the city centers, to harvest water to support greening the city. And in the case of the true cost of water, water is harvested also, but this is really to save it for future use. So these are some maps that are produced from the maps that the practitioners, the participants in the workshops developed, and these were translated, given the rules that they produced, to create these maps following a base map for the Phoenix metropolitan area. And you can see that there's quite a bit more green in the Emerald City scenario to the right. Now that green is not just evenly distributed. As I said, it's concentrated in these hubs that are crossing canals and freeways. Much less green that you can see in the true cost of water. The orange is agriculture, and you can see it's still outside the city in both cases, and in some of the other scenarios, it was actually brought into the city more. But what are the consequences of this? And one of the things we can do with having these maps is that we can actually feed these into models. So a colleague is able to run the weather research and forecasting, I think it is, model to examine the heat consequences of these two different configurations of a future Phoenix. And what you can see, of course, is that this greening and distribution of capture and distribution of stormwater across the city to support green infrastructure results in a much cooler and pleasant Phoenix than the one on the left. These are just comparative numbers, so you can see that the heat outcomes for the saving water and having much less green are pretty severe compared to the Emerald City. So this is one outcome, but we can think about what the trade-offs are associated with the way that this water is handled. And so using the model that's been developed by Arizona State University called WaterSim for this region, we were actually able to develop this map, this analysis of how much water could be banked for future water security. And what you can see is that although both are banking water to some extent, that's much, much greater. So this kind of an analysis will allow decision makers to actually look at the potential trade-offs and between different courses of action and thinking about those future scenarios. We also have analyzed the scenarios at two different scales using a qualitative assessment that was developed by Marta Beves. And in this, we found primarily that there are real differences in what is valued and desired for the future. As I said before, there's more emphasis at the local scale on these normative elements, including social equity, participatory governance, and a sense of place, and more emphasis at the regional scale on ecological values and design. Excuse me. So if you see on the bottom, these are scores in this rescue, we call it rescue qualitative assessment, for the local in green and regional in brown, three measures of equity. We also did this analysis for resilience and sustainability. So I hope this has illustrated to you how these future scenarios both can be used to compare across scales, across cities. I didn't talk that much about the comparison across cities yet, but really thinking about a positive future involving humans and nature interacting together in urban areas. And I wanted to take a little bit of time, if I have 5 more minutes, right? Okay, just to talk about a couple of other things that I've been working on. I am, as I said in my introduction, I think we're in an urgent situation where we really need to think about how we're going to radically change the way that civilization is working, the way that we're interacting with nature, the way that we're interacting with each other. So the question is, who will be solving the big problems that we face in this age of change? And the answer, I think, is that it's the early career people, the people that are coming up. And so I have been very interested in starting this sort of rethinking the way that we train graduate students by creating the Earth System Science for the Anthropocene Graduate Scholars Network. And in this network, we're basically promoting a way of learning about doing participatory research, like I talked about earlier, but really thinking also about bringing very diverse disciplines together and having people learn how, in graduate school, how they can interact across these different disciplines. The only requirement for people to be part of ESSA is to acknowledge these 3 core values that we hold, that we promote just, equitable, diverse, and inclusive research, that we focus our research on finding solutions for problems of the Anthropocene, and that we acknowledge that there are diverse ways of knowing, understanding, and producing societally embedded research. So we have been building this community of ESSA scholars, and most recently have developed a program called Weaving Relations, in which we conduct these immersive, interdisciplinary, identity-based team science experiences where students are embedded within communities, developing solutions-driven research. And we have designed this particular program to promote Indigenous and Latinx scholarship at the graduate level. To do this, we do a spring short course that's led by the faculty that you see there, and then provide funding for students to do participatory research during a 10-week summer session. And some of the outcomes that have been produced in some of these things that we've worked on, we had a group that was working on understanding of the Salt River, and one of the really creative things that came out of this was this game that's on the left, and you can actually download the game. It's in English, but it's also being translated, I think, to Accomaathan language. But the idea is, is something about the way that the critters in the river are actually able to survive by working together. And this game was developed and has been transferred to schools in the neighboring Indigenous communities. And then finally, Natura, which is what we call the nature-based solutions for urban resilience in the Anthropocene, is this network of networks globally, nearly 50 networks, that is working on nature-based solutions in cities. This is the most recent all-hands meeting that we had in Miami, which was kind of nice. This is being led by, in addition to me, Elizabeth Cook, Timon McPherson, and Loan Deep as our postdoc. And we have a coordinating committee with members from across the world. Our goals are to exchange knowledge, share data, enhance communication among research disciplines, and across the research practice divide to advance understanding of how to build resilience. And some of the findings so far are, we've been framing Natura in terms of this social, ecological, technological systems framing. So we can see that various solutions, which this is probably too small for you to see, but in a typical city that we have solutions that range from pure ecological to technological, social to social, ecological, socio-technical, and finally out to sets kinds of solutions. One of the things that's very exciting about Natura is we have a very active early career network. These are 2 photos of the early career scholars from our first meeting in Malta and our recent meeting in Miami. They are academic researchers as well as practitioners, and they meet monthly, and we provide fellowships for students to exchange across networks. And this is the website and some more information about Natura. The website is listed there. So all the work I've presented today is about bringing nature into the city, integrating ecological with social and technological domains in building resilience of desirable states to improve the chances for ensuring that cities of the future are places where people can thrive in a rapidly changing world. So thank you for your attention.